Hey everyone. Excel is certainly an unusual environment for the development of artificial intelligence, but for the scale of my neural net, it will do. At the entrance, we feed a matrix with a resolution of 2 cells. In it we draw 2-cell lines, and the neural net must learn to distinguish vertically or horizontally line. And that's the whole task. Of course, lines can be right, left, top, or bottom. There can be both options, like this, or not a single unbroken line. At first, I determined the structure. I chose the feed-forward neural net, the simplest. So, it has input layer. Everything is simple here. If the neural net receives a signal from 4 cells, then there are 4 neurons at the input. 2 inner layers. I had to experiment with this. When there was 1 inner layer, the brain did not train. Therefore, if the neural net is not being trained, the structure for this task is probably small. And the output layer. Here, you need to determine the number of answer options. Are 4 of them in my task? Horizontally. Vertically. Both options. And not a single one. 2 neurons are enough for this. So, we implemented the neural net in Excel. A link to the file will be in the description. The file has signed all columns. If you click on the formula bar, you can see what it contains. Those who wish can figure out what's what. Also in the file I wrote simple macros, which are doing copy-paste several thousand times instead of me. So, 0 the weight values. They randomly fill values close to 0 in them. Various combinations of initial weights affect the learning ability of the neural net. There are the stages of training. First, we provide training data to the input layer. Second, we calculate the direct activation through the chain of layers and neurons, the activation of output neurons. Third, compare with the correct answer and calculate the error on the output neurons. Fourth, according to the principle of backpropagation of errors, we calculate errors on all previous neurons. Fifth, based on the errors obtained, we calculate the gradient for each weight. Sixth, calculate the atom optimization for each weight. Seventh, calculate the values of the adjusted weights. Eighth, insert new weights in place of old. And we return to the first point and submit the next training object. All 16 training objects are dataset. It contains 16 combinations, 4 input neurons and 4 variants of correct answers. One epoch of training. This is when the entire dataset went through the neural net. The neural net undergoes training for 150 to 200 epochs. This time is 3 minutes. In the macro, I registered that with 0 errors out of the last 500 attempts, stop learning. About bias neuron. For activate the output neuron, I take a factor of 0.8, and to deactivate 0.2. The values in the middle, this is an uncertainty. So, to select the value of the bias neuron, I put zeros on the input, and on the output I want to get a little less than 0.2, maybe even less. But I saw that the training of the neural net was slow. Therefore, I settled on the value of the displacement neuron equals 1.5, with input zeros, and the activation of all neurons became about 0.18. About learning speed. Experimentally, we choose the learning speed for a specific structure. As I understand it, You need to find such a minimum value that slowly, but still gradually, changes weights. Some go to positive, others go to negative. If the weights trample on the spot, then the training speed is too low. And if the speed is much more than this minimum, then the neural net will quickly relearn, the weights will go off the scale, and nothing will come of training. We start training. And wait. While I was doing it, the thought arose without changing the structure to teach her to recognize colors. Let's see what happens. So, training is over, the neural net gives the correct answers. Thank you for watching.